Good morning. Today we are going to discuss about Gauss divergence theorem, which is displayed on the screen. Gauss divergence theorem. So last video lo Stokes theorem completed proof statement. So here today's Gauss divergence theorem. Statement. Let us consider. So statement is displayed on this screen. The normal surface integral of a vector field A over the boundary of closed surface S is equal to the volume integral of the divergence of a vector field over a volume V. Here simply surface integral is equal to volume integral. Surface integral is equals to volume integral, that is surface is equals to volume. This is the Gauss. So detailed explanation is, let us consider ఈ స్టేట్మెంట్ కూడా రాసుకోవాలి మీరు నోట్స్లో. ఈ స్టేట్మెంట్ రాసుకోవాలి. లెట్ us కన్సిడర్ a closed surface S enclosing the volume V. Suppose that divided into small volume elements, each of volume dV, whose sides along x, y, z axis are dx, dy, dz respectively. So let us consider a closed surface. క్లోజ్డ్ సర్ఫేస్ని కన్సిడర్ చేసుకోవాలి. ఎస్ వాల్యూమ్ వి. సో సపోజ్ ద డివైడ్ ఇంటూ స్మాల్ వాల్యూమ్ ఎలిమెంట్స్ స్మాల్ వాల్యూమ్ డివి, total volume V. So we consider small volume dV, sides along xyz. So dx, dy, dz elements respectively. Draw a figure. X, y, z origin, so along x axis dx, along y axis dy, along z axis dz. So this is the left face, this is the right face. So here it is a figure. So divergence అంటే ఏంటో డెఫినేషన్ చూద్దాం. divergence. So it is defined as the amount of flux per unit volume. Divergence definitions: the amount of flux. Flux means simply the rate of flow, nothing but energy or something distribution. The rate of flow ni మనం సైన్స్లో ఫ్లక్స్ అంటాం. రేట్ ఆఫ్ ఫ్లో. సో ఎనర్జీ ఫ్లో అయిందంటే పర్టికులర్ ఏరియా నుంచి సమ్ ఎనర్జీ ఫ్లో అయితే ఆ పర్టికులర్ ఏరియాని ఫ్లక్స్ అనొచ్చు. సో ద అమౌంట్ ఆఫ్ ఫ్లక్స్ సింప్లీ ద రేట్ ఆఫ్ ఫ్లో. డైవర్జింగ్ ఫ్రమ్ ఏ పాయింట్ పర్ యూనిట్ వాల్యూమ్ in a vector field. So the amount of flux. So first for suppose particular ఇక్కడ నుంచి ఫ్లక్స్ అనేది ఎంత డైవర్జ్ అవుతుంది, అమౌంట్ ఆఫ్ ఫ్లక్స్ డిఫైన్ చేసేది డైవర్జెన్స్. సో we consider surfaces volume v over boundary xyz axis along x axis dx dy dz. ఇది రైట్ ఫేస్, ఇది లెఫ్ట్ ఫేస్. ద అమౌంట్ ఆఫ్ ఫ్లక్స్ మనం డిఫైన్ చేసేది డైవర్జెన్స్. సో లెట్స్ సీ. ఇది statement the normal surface integral over a closed surface is equals to the statement the normal surface integral over a vector field A or the boundary of closed surface S in equal to the volume integral. So S ikkada surface integral is equal to the volume integral of divergence of a vector field or volume V enclosed by the surface. This statement is in mathematically we expressed as surface integral. So here surface integral, that means closed surface. Here a bar is a vector, that is which is in the statement a bar dot ds bar is equals to or a volume is closed surface is equal to volume integral is equals to volume integral, that is div a bar dv. So that is which is also expressed as del bar dot div ni del bar dot a bar గా ఎక్స్ప్రెస్ చేయొచ్చు. del bar dot a bar dv, del bar dot a bar dv. This is the mathematical expression we need to prove of Gauss. So proof: the value of the vector along x-axis at left face, that is ax. The volume of the x-axis at the left face, that is vector a. So along x-axis ax, the value of the vector along x-axis at right face of small volume element. So here value of vector along x-axis, that is ax, volume of vector along x-axis ఇక్కడ left face, ఇక్కడ right face is equals to ax plus dou ax by dou x. So this is the rate of incrementing. Next, the flux entering at the left face along x-axis is ax dy dz, that is equation 1. The flux, సో ఇక్కడ డయాగ్రామ్ వేసుకుంటే the flux entering is, ఇది entering, flux entering, that is ax dy dz. Next the flux leaving, from the right face of volume element along x-axis, that is ax plus rate of change of a along x, dou ax by dou x into dx. సో ఇందాక ఎక్స్ ఎలిమెంట్ ఏఎక్స్ అనుకున్నాం. సో ఇక్కడ ది రేట్ ఆఫ్ డో ఏఎక్స్ బై డో ఎక్స్ ఇంటూ డిఎక్స్. సో టోటల్ ఏఎక్స్ ప్లస్ డో ఏఎక్స్ బై డో ఎక్స్, ఇది ఎంటరింగ్, సో ఇది లివింగ్. డో ఏఎక్స్ ప్లస్ డో ఏఎక్స్ బై డో ఎక్స్ ఇంటూ డిఎక్స్ డివై dz considered as equation 2. So net flux, total flux entering, leaving, total flux. Net flux along x-axis, that is dou ax by dou x dx dy dz. ఇక్కడ dou ax by dou x means the rate of change of a that along x-axis. Dou ax by dou x into dx dy dz considered as equation 3. Similarly along x-axis, similarly along y-axis, that is dou ay by dou ay by dou y, dou ay by dou x. Next along z-axis dou a z by dou x. Similarly net flux along y-axis, that is dou ay by dou x dx dy dz, equation 4. Similarly net flux along z axis dou a z by dou x dx dy dz. Equation 5. Total flux. Flux means rate of flow. Total flux through entire volume V total flux through entire volume dV is equals to dou ax by dou x plus dou ay by dou y plus dou az by dou z dx dy dz. So here total flux through entire volume V, here entire volume dV. So here entire volume V, that is I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. Next I cap ax plus j cap ay plus k cap az dx dy dz. So this is expressed as I dou by dou x plus j dou by dou y plus k dou by dou z is del. We know that ax ay az, so del dot a. So dx dy dz, that is the value. Equation 6. Total flux through entire volume. Total flux through entire volume is del bar dot a bar into dv. Equation 7. Total flux through the closed surface, which is the enclosing the volume V. Total flux through a closed surface, which is the enclosing volume V, that is we can express as a bar dot ds bar. So equating 7 8, that is surface integral a bar dot ds bar is equals to div dv. Also del bar dot div ini del bar dot a bar చేయొచ్చు dv. This is the Gauss divergence theorem proof, which is defined as the amount of flux diverging from unit volume.